I take now is to share with you so that if your expansion is coming, okay, because I can see the growth and we do it right day one. Okay, so this is where I think it's important to share with you the importance of doing it with data and information so that you can do it correctly. Okay, so with that, then next thing is come to PV, where Christoph will later will share with you how PV can help you to use the energy using our natural resources. Okay, next. So we can actually go into even technologies like robots, okay, and digitization. How? Because all this digitization can help us to reduce your feed wastage of feed, you know, overfeeding, and also temperatures, oxygen content of farms. All this can be monitored, and it can be actually also through your cell phone computers. We can measure all the performance. That also help us to reduce consumption. And also manpower. Now, the thing is that 2 days ago, I didn't put up this. 2 days ago, IMDA have a grant called Digital Assistance Package for SME. If you are SME, there is this grant which is approved by IMDA, 80%. I didn't put it here because it's only 2 days ago. It's a 35,000 grant, pre-approved funding. If you want to know more of this grant to help your industry to put in instrumentation, digitize your farm, I suggest you can give a call to CIS and arrange to meet up and see how we can help you on this. Okay, so this is where I didn't put up here, so at least you know that there is some funds to help you in this industry for those SME only. Okay, next. So we have a couple of different industry came to us. As you can see, all industry, the usage of energy, usage of waters is all different. So we have to actually sit in together with you, okay, and go through how to help you to make sure that the design one is efficient. Okay, besides, I know that you have the know-how how to grow your vegetable, your fish. Okay, in terms of how to utilize, in terms of equipment, we can help you. Okay, with CIS EE members, right? Thanks. So that's an overview of what EE member can help in this industry. I hope that we can give you some idea, okay, how to help you to make sure that day one design correctly, so that we can all of us reduce consumption and save our planet. Thank you. Okay, pass back to.
Sure. Thank you very much, Vincent. Thanks a lot for your insightful presentation on energy management. I would now like to invite Mr. Christoph Englin, Managing Director, Energetics, who will be giving us an overview on harvesting sunshine for Singapore's farmers. Christoph, please.
Okay, great. Thank you very much, Shabnam. Just confirm, please, can you see my slides there?
Yes, we can.
Great. And Vincent, thanks for your introduction there. I think people often overlook in the excitement of generating renewable energy and everything like that, one of the best ways to save money is to use less energy in the first place. And it's just like, if you want to lose weight, eat less, don't go and buy an expensive exercise machine. But it's not always so easy. We can do both. So I'm looking at, seeing as you're in the farming sector, how do you harvest sunshine directly? So first introduction, because I know not everybody is on the same page when it comes to PV. The acronym stands for photovoltaics. Photon is light, voltaic is electricity. So we're about turning sunlight directly into electricity. Give you a very brief illustration. Solar panels, I think now more and more of us have seen them. Anyone in Singapore who hasn't seen them yet on the HDBs must have been living under a rock, because there have been so many installed in the meantime. So these panels are typically about 2 meters long by 1 meter wide, and you connect them in series in what we call a string. There may be 20 panels in series, and then several strings in parallel. And the more in series, the higher the voltage. The more in parallel, the higher the current. Voltage times current is power. That feeds into an inverter, which converts the DC electricity generated by the panels into AC electricity. It then feeds into the AC distribution board or your main switchboard. Meanwhile, in parallel, you've got the power grid coming in through the substation and the electricity meter, also feeding in the same main switchboard. And jointly, these two sources of electricity power everything in your house that is connected to the MCB, to the main switchboard. So that's your water heater, your washing machine, your computers, your fan, your aircon, your toaster, your TV, you name it, electrical devices are all powered by that. You can think of it like having two streams of water feeding into one river. And downstream from that river, you drink electricity. You don't know which stream you're drinking from ultimately, as long as it feeds into that river. So next, in other words, there's no changeover switch. So we don't have, like, if there's a power cut from the mains electricity, switching over to a diesel genset. As long as the sun is shining, you are feeding solar electricity in parallel with the mains. And that's for a grid connected system. So here, as soon as the sun strikes the panels in the morning, they generate the DC. And my animation is not working properly. Okay, you would see AC electricity coming here, and the grid meanwhile also powering it, turning the meter forwards because you're drawing from the grid as well, and the load's being powered. Let me just go back, sorry. That's in the morning. Beg your pardon, I got ahead of myself on the slides. In the early morning, here we go. AC loads are turned on, being powered by both the solar and the grid. At midday, it could be that your solar array is generating more electricity than the house or the home needs. The only thing running might be the fridge. The air conditioning is off. So excess power will go back out towards the grid, and the meter would spin backwards if it's an old mechanical one. In our case, we have digital meters. One register records what you consume, one register records what you export. And finally, at nighttime, there is not enough electricity generated, in fact, zero from the solar panels. You are then powered 100% by the grid. So that triggers a question: how much of my building is being powered by the sun at any one time? The answer, of course, it depends. At nighttime, I guarantee you zero. In the daytime, anything from zero, when it's very, very cloudy, to more than 100%. Let's look at what's been driving the market recently, because many people still have, they labor under old concepts, old ideas, and that leads them to mistakenly believe that PV is not cost effective or they need some subsidy to make it work. All that is nonsense. For a long time, you see here on the left, the axis is in US dollars per watt. And back in 1976, so nearly 45 years ago, you were looking at $80 per watt. The cost of PV came down quite rapidly. But meanwhile, on the other side, I've got the annual installations, and you see the orange curve, nothing's moving. So for the first few years, basically the cost came down quite rapidly, the first few decades, because of R&D investment. So R&D was driving the cost down, but still not attractive enough for people to invest in it without subsidies. Then there's a period of time when subsidies were the driver, mostly in Japan, Germany, United States, where the government decided to kickstart the market with subsidies. And then at a certain point, the net price after subsidy became attractive enough for people to invest, and you see the market picking up. Then we see the final phase here, which we're in now, is a good phase. Commercial viability. The cost of PV has come down so much, so it's fallen by a factor of 300 since 1976. And that makes it commercially viable without any subsidies. And you see the tremendous takeoff in growth here. So this is up to 2018. The last 2 years, that number has nearly tripled. This is good news. Why? Because although I know some speakers will come later from the government talking about grants, between you and me, you can't trust politicians, because they're the ones in control of subsidies, and they take them and they give them and they take them away again. Much, much better. Everybody's happier when the market works on its own merits, and then you don't need somebody in the middle to be tempting you with a subsidy. You simply buy what makes sense for you. Okay, let's look at how those market drivers push the market in one of the pioneering markets, which is Germany. So you see here from 2002 until 2019, they have a very varied power supply. Singapore were just with gas, basically, but they have nuclear, lignite, which is brown coal, anthracite, which is black coal. Then there's gas, hydro, biomass, wind, and PV. And the thing is, back in 2002, including hydro, which is kind of mainstream renewables, the renewable energy share was only 8.8%, call it nearly 9%. Fast forward 17 years, and it's nearly 50%. So from year to year, it didn't seem to be making much difference, but suddenly it's grown a lot. There are 3 milestones on the way. In the year 2012, wind energy overtook gas in terms of energy supply. 1 year later, biomass contributed more than gas. And from 2014, PV contributed more than gas. And now we're seeing PV being about 10% or so, and the whole of the renewables very, very fast. Certain days of the year in Germany, they need to practically switch off the conventional power because between PV and wind, it's supplying nearly the entire load at midday. So that's encouraging news. How does it look in Singapore? Well, in Singapore, things have been a little bit slower. We didn't have the advantage of subsidy-driven growth in the early years, but from about 2014 onwards, things picked up thanks to initiatives by BCA encouraging new buildings to install PV on them to reduce their net energy. Here you see a small dip. This is when conventional power got very cheap briefly, and it set some of the ambitions back. But in the meantime, PV is cheaper than any conventional power supply. It does depend on what you're comparing against, but in most of the world now, PV undercuts even coal. And that has driven quite high penetration levels. The Energy Market Authority was very pleased to announce early this year that we have already, as a country, surpassed the goal of 350 megawatts installed, which was to achieve that by 2020, and now set a new, much more ambitious target of by the year 2030, having 2 gigawatts. What will 2 gigawatts achieve? Something like 30% of peak power and something like 6 or 7% of the daily energy. So it's a small but significant factor. What does this look like? Conventionally, we have Singapore here with kind of out of sight, out of mind, mostly on Jurong Island, a bit in Tuas and something in Woodlands, conventional power plants. In 2014, 97% of our electricity came from a handful of these combined cycle gas turbines or cogen, trigen plants. Roughly 13 gigawatts of installed capacity and a small amount of the pipeline. Then Singapore got measles. So as of the end of last year, we've got the 350 megawatts nearly installed, a backlog of well over 150 megawatts, and the number of installations. These figures are published quarterly, about 3-4 months in arrears by EMA. So the different regions in Singapore, you see them added up here, how many systems are installed. So now nearly 4,000 sites. Each of these is a generator. So it really changes the way that our power industry is working. Instead of having just centralized plants, which are controllable, you have lots and lots of small distributed generation, which is not under our direct control. It's under the control of the god Apollo, the sun. And that, of course, varies according to the clouds, which jump in front of its face. So let's look at the economics. What does this mean for you as somebody who wants to harvest the sun? How can you earn or save money? There's many complicated spreadsheets you can do, but easy way is first a kind of back of the envelope calculation. Firstly, how much energy are we getting? 1 kilowatt peak, which is about 2.5 large modules these days, will generate 1,200 to 1,300 kilowatt hours in Singapore if it's on a well-exposed rooftop. And the costs have come down a long way. We're looking at about 900 Singapore dollars per kilowatt peak. In other words, a megawatt peak system will cost $900,000. So how does your payback work out? Sorry, it is your cost per kilowatt is here, $900. Your energy yield, I'm taking the average of these two figures, so a conservative number, 1,250. And what is the tariff that you're competing against? These numbers are giving 4.8 years. So a payback or ROI, return on investment, in 4.8 years, less than 5 years. What does that mean? That corresponds to an internal rate of return, or IRR, of about 20%. So it's a very good figure. And then what happens if your yield varies because you might not have such a auspicious rooftop? You may be more shaded by trees or neighboring buildings, so it could be a bit less or a bit more. And maybe you're paying a cheaper price or a more expensive price for electricity. So you're varying between at the cheap end and the low sunshine, 7.5 years. And if you've got the best combination, high sunshine, good yield, and a relatively high tariff that you're offsetting, 3.5 years, which is an incredible investment. Because that money sitting in the bank, as we all know, earns you nothing. I've got a note here, low tension consumers make better returns than high tension. Why? Because the low tension price is often higher and is all inclusive. High tension have a lower variable cost of electricity, but that hides also the fixed contracted capacity charge they pay, which you have to amortize, and typically adds about 3 or 4 cents to your tariff, which you cannot offset with the PV. So the best combination is a large roof, low tension customer, and then you really make good savings. The savings, again, are determined by one more thing, which is how much do you consume yourself at your avoided tariff, and how much do you end up generating over and above your consumption, which ends up being exported at wholesale tariff. That's basically the price that the generators sell to the pool for, and it is significantly lower. So this example here shows a building with a 400 megawatt hour monthly demand, continuous load is 720 kilowatts, and this is a 1 megawatt peak rooftop. On a rainy day, like we had this morning, you generate almost nothing. So you can have a very, very bad day. All of that electricity is consumed in-house. On a very sunny day, well, like this afternoon, you can be exceeding your demand. And on average, you'll consume it more or less all in-house. So depending on the size of your system relative to your demand, the sunshine and your tariffs and the wholesale tariff, that makes the mix which determines your return on investment. How does that wholesale tariff vary? It changes. In the past, it was quite high. You see here, Singapore dollars per megawatt hour. So $100 per megawatt hour is the same as 10 cents per kilowatt hour. In the years 2010, 2012, 2013, we were there above 20 cents per kilowatt hour wholesale price. It dropped to an all-time low of about 6 cents per kilowatt hour in 2016, rose again, and is now back down around that level. The lower chart shows the variation. So these red dots correspond with the blue lines here. The lines correspond to the extremes. So at certain times of day where you get maybe 1 or 2 power plants under maintenance and another one falls out, then prices hit a peak. They're capped at $4,500 per megawatt hour, which means $4.50 per kilowatt hour, roughly 20 times the normal tariff. And they can go negative, but almost never do. As you see in recent years, because there's an excess of generation capacity, that has somewhat curbed the enthusiasm for high prices, and we're currently low, but long term, they will probably rise again. And all these data you can download from the internet. The website is there. That brings me to the kind of closing slides. How do you operate your business? Now, I'm concentrating here on grid-connected systems. Later, our friend Hu Yao will show you what happens if you're off-grid, like let's say a fish farm. We did a project together where we installed the PV, he installed the battery in the control system. So there you're not grid-connected and you need a battery. Batteries don't make sense in grid-connected systems. They do make sense in off-grid. So dealing with on land, you are connected to the utility. You are the building owner. You invest in putting PV on your roof, a contract with an EPC contractor, and then an O&M contractor who maintain it for you, sorry. And you recover your investment in terms of offset electricity consumption. So a very simple CapEx model. It's like buying your HDB and you don't pay rent, so that's your saving. But what happens if you don't have the spare cash or bank facilities and you prefer to spend money on your own business? Then you can do what's called a leasing or a power purchase agreement. You as a building owner, you're the host, you pay no upfront investment. You negotiate basically a discount on the tariff for the electricity you consume, and there's no take or pay risk. The special purpose vehicle or the leasing company exports a surplus PV at wholesale tariff. It's a bit more complicated. You're the building owner. You have a contract with this investment company here. They in turn contract with an EPC company, have an O&M contractor, and they most likely borrow money from a bank as well to set the whole thing up. In contrast to a system where you are the investor yourself, something like this takes a bit longer. There's more parties involved and it's more complicated. When do you choose which model? Direct ownership is advantageous if you consume all the electricity in-house. You have the money. You're a technically confident company to either carry out or to supervise the contract. Fundamentally, you prefer owning to renting. This is a bit like some people just want to own their property, others prefer to rent. It's a kind of religious preference. There's no right or wrong. If you might want to sell the building within 20 years, it's a lot easier to sell the building with a PV system on it that you own. It can be quite tricky to sell it and then convince the new owner that they must take over your lease contract. So that's something to consider. When you want to go into a leasing contract or a PPA, you've got no funds. You prefer somebody else invests. The investment doesn't meet your investment criteria, or you have a complicated budget approval process. Fundamentally, you prefer asset light. You want to rent rather than own. And you prefer to outsource non-core business operations. All nice, so it depends on your circumstances. Now, what happens if you cannot undercut, if the PV cannot undercut the building's retail tariff? You could be a very, very large consumer and have a very, very low tariff, and it's not possible for the investor to sell to you even cheaper and still make a reasonable return on their investment. Or what happens if you end up exporting a lot of your production? And furthermore, the lower net grid demand reduces your negotiation power, which is the reason you have such a low power price. There's a third model, which is being explored in Singapore, which is roof rental. Here, an investor will come and basically intermediate between you who have the roof space and surplus production, and customers, let's say in Suntec City or some Mapletree, who don't have their own rooftop but want to buy the green electricity. This person will have a retail license, rent your roof space, pay you to basically rent it, and all the electricity generated belongs to this investor who sells it on to these companies here. So it's a bit like the leasing model, but has a slight spin on it. Okay, that brings me to the last slide. Two conclusions. Don't ignore your roof space. Build it to worship the sun and to harvest electricity. Use it wisely, in other words, because you can make money from your roof. And then the environmental benefits that people talk about are actually a happy coincidence. Most people invest in PV not to save the planet, but because they save their wallet and make money. So that's the last slide. Happy to hand back over to Cees to take on the next presentations.
Sure. Thank you very much, Christoph, for your presentation. I would now like to invite Dr. Michael Obando, Managing Director of Ocean Pacer, to briefly share about marine renewable energy solutions for fish farmers. Michael, please.
Good afternoon. So I am the current chair for the Marine Renewable Energy Working Group of the Sustainable Energy Association of Singapore. So I know that there are not a lot of, should we say, coastal or offshore fish farmers here, but perhaps in the future, and maybe you have colleagues as well that could find some relevance into looking at sustainability solutions for marine and coastal activities. And I limit them to those that touch the marine waters, but also wet environments, could be inland as well. So next slide, please. In achieving the Sustainable Development Goals, there is now a growing impetus to look at the sustainable blue economy that is similar to what has been happening on land and still is sort of rolling out on land, where people look at green initiatives and the green economy. Similar things would happen in marine and maritime space, which is termed as the blue economy. where you don't have just renewables coming in, but sustainable food production, logistics, and all other sectors that use the marine space. Next slide, please. In this space, you can have sustainable integrated development, obviously, and a lot of islands and coasts have been initiating activities around different sectors. Looking at renewable energy is just one part of the equation, and electrification is just maybe one start of things. But the end use is really interesting because it could be in transportation, it could be in aquaculture and fisheries, it could be other applications like water production, ice making, etc. So in Singapore, there is a microgrid project at this multi-agency as well on Semakau Island, and it's called REEDS, the Renewable Energy Integration Demonstrator Singapore, and that showcases hybrid renewable energy systems coming together to look at powering loads, electrical loads on the island, and benefiting the end users that are either on the island or near that space. Next slide, please. So this is a simple notion that I'd like to also educate the rest of the world to just make sure that there is clarification. There is a difference between marine renewable energy and ocean renewable energy. So marine renewables are renewable energy production which makes use of marine space or marine resources, and ocean renewable energy is a subset of marine renewable energy. So when you talk about marine renewables, you're really talking about anything and everything that uses the marine space or marine resource. Like floating solar panels on the sea is marine renewable energy. Wind turbines that are located in the sea offshore are also considered marine renewables. Use of marine biomass, algae for instance, for energy production is also marine renewable energy. Now ocean renewable energy is a subset of that, which makes use of ocean dynamics that could be driven by other forces such as these five. So currents, tides, waves, the difference in saltiness of the water. Yes, you can harness even that, and the difference in the temperature of the water. Surface water will be hot, and you go a bit further deeper, and then you have a difference of a few degrees. If you go deeper than a certain amount, then you have enough difference to run maybe a turbine. So next slide, please. This summarizes the 5 ocean renewable energy resources globally that's being explored. And obviously, there are certain technologies that are more mature than the rest. For instance, currents, harnessing currents and waves using energy converters are more mature than those of the ocean thermal energy converters, which harness thermal gradients and salinity gradients. Salinity gradient technology makes sense for co-applications. If, for example, desalination, where you're producing water, and from an energy efficiency perspective, you may want to make use of the very salty water, and it's going to be pumped back to sea, which is then a difference in saltiness that you can take advantage of. For harnessing tides, the technology is called a tidal barrage, which has a lot of environmental impact, and that has been known. Now we have large tidal barrages in the UK, in France, in Canada, and now in South Korea. But the environmental impact is way too high, so people are moving away from that and more into more hydrokinetic energy systems, such as those turbines you can put in flowing water. Next slide, please. So in Singapore, there have been some studies by the Energy Research Institute, as well as other groups we've looked into, and this is available in the position paper as well in SEAS. There's a potential of practical potential of 250 megawatts of tidal in-stream energy that could be installed in some strong current locations in the southern side of Singapore, or even the northeast side of Singapore. For wave energy as well, estimated of around 50 gigawatt hours per year, using the shores of Singapore, where there could be some wave. I wouldn't say strong wave, but some wave. So floating systems are cheaper than, of course, those that are submerged. So looking at floating systems and hybridizing them using multiple renewable energy technologies, for instance, floating PV or floating photovoltaic, which is a technology that's used to harness solar energy, combined with, let's say, a wave energy converter or a tidal turbine underneath a floating platform may make sense to make your investment worthwhile and harness more energy in the same sort of location if the resource is there. Next slide, please. So here are some other applications. I won't go through them, but same with other renewables. You can look at utility scale, you can look at distributed scale and off-grid. At this time, you also have offshore applications of marine renewables. Then powering coastal operations and activities, looking at green, marine, and maritime ecosystems, which is something that you have for those in the marine environment. You typically have operations that use energy, like boats, vessels, and your fish pens require lights, and your feeder barges require power. So these are things that we can explore using cleaner energy options and low carbon technologies. Next slide, please.
Other projects in the region, in Singapore.
Don't play that.
Floating, tidal.
Thank you. So just showing the slide here where we have a floating tidal turbine system that has a little bit of solar and also a diesel genset on board for backup. So these floating systems could potentially be future of marine operations that are not diesel based anymore, but a hybrid. So next slide, please. So there are projects that use marine renewable energy technologies working with existing systems like diesel generators. So this is a tidal turbine and installed in West Papua of Singapore. Next slide, please. So just showing you local barge with a cable through the air and a pole sort of in the water there, because the locals are more keen to cable through the air rather than submarine cable. Next slide, please. So this case study shows you what a hybrid renewable energy system could potentially mean in terms of savings. And we know energy efficiency already gives you savings. Having solar is a worthwhile investment, but having also, depending on case-by-case basis, multiple renewable energy sources could potentially also yield better savings than just utilizing one. Next slide, please. So the opportunities for Singapore is looking at different areas of application, like energy and water security, for instance, a combination of socioeconomic growth, addressing climate change, and of course, export potential for the region, in case you want to grow your business beyond just Singapore in terms of food production nationally and also beyond, right? Next slide, please. So really for fish farms, there is some basic work that you need to do in terms of an energy management problem or energy management scenario. So fish farms that we've talked to, there's in the region as well as outside the region, in Australia, New Zealand, for instance. Yeah. So they do have operations that look at 10,000 tons of salmon or fish production per year, right? And they have 12 to 16 fish pens that they have lights, and they have feeder barges, and they have harvesting operations. And so all these things could potentially be using cleaner and greener technologies. So in the operations that are coastal and marine, depending on what use case you have, you can implement marine renewable energy plus energy storage systems plus low carbon technologies like electric boats, for instance. Next slide, please. Here's an example of what a hybrid marine renewable energy system would look like. So you have floating solar, you have a floating tidal system. You could combine those. Maybe on land there could be solar as well, and energy storage systems working with, let's say, a diesel genset if you're off grid. If you're grid tied, then you just tap onto the grid. And you can even have other applications, telecommunications, for instance, and local water desalination, for instance. Yeah, next slide, please. So this is to give you a scale. Let's say if I had a 10 kilowatt load that I require, this is maybe I would like to have an 8-hour operation with 10 kilowatt worth of power because I have maybe an air conditioning unit, I have an electric boat, I have a feeder barge and lighting or other things that I require energy. So if I were to look at just a purely solar system, a marine floating solar system would require 140 square meters of space. I may have that if I'm a K-long plus and fish cages. For tidal current turbines, because the energy density in the water is so high, I need less space to harness sort of the same amount of power. So the surface space would be maybe 35 to 70 square meters, but I could harness twice to maybe 5 times of what the solar system would be, or maybe half that space. So hybridizing these things, solar and tidal, actually makes sense so that you can generate more for sort of using this, real estate, right? And there's an optimal mix that's always could be managed. Next slide, please. So potential pilot projects in related to food and agriculture and coastal operations could be any one of these, any combination of which. If the end use case is defined properly, then the energy use is also sort of defined properly. So then we can craft projects around what will be useful and basically value adding for everyone. Next slide, please. So this is just looking at jetties and looking at the deployment systems that harness things in Singapore, waves and currents and solar at sea. And there are multiple deployment options that you can look at. Next slide, please. So as a summary, we do have marine renewable energy options in Singapore. Waves and currents may be OTEC and salinity graded, but we need resource inventory to double check. A green marine and maritime ecosystem. Low-hanging fruits include electric boats, for instance, right? And looking at aquaculture or water production and through desalination. And this progressive development approach, where you start off with maybe smaller projects and pilot projects before you roll out into something bigger, will normally develop a lot of capability, and especially in the local supply chain. So these pilot projects will be taken with a grain of salt, but it is possible to roll out progressively. Next slide. Thank you very much. I think that should be my last slide. Back to you, Xiao.
Yep, sure. Thank you very much, Michael. Next, we have Mr. Hu Yao Leong, Project Manager of Megawatts Engineering Services, to share about solar hybrid system at sea. Mr. Leong, please.
Hi, good afternoon. Many thanks to SEAS and CFF for organizing this event. So I could share my experience and knowledge in harvesting clean energy for farms in Singapore. Next slide, please. Next. In the recent years, fish farmers experiencing challenges such as climate change, water pollution, which affecting fish supply in Singapore. Next slide, please. To counter these challenges, my client had developed smart fish farms with enclosed tanks, like the tanks in the picture, blue color. The farms are in the middle of sea, which has no power supply from power grid. Megawatts has provided microgrid solution to power the fish farms with solar panels act as roof. This solution is aligned with Singapore plan being less dependent on fossil fuel and moving in the direction of clean energy generation. Next slide, please. In the old days, people used diesel generator or having unstable power grid or insufficient incoming power supply to meet increasing electricity consumption at farms. Now, there are clean solutions for supplying electricity by using solar PV or solar PV hybrid system, which allow them to have electricity even at off-grid area. Next slide, please. Economic for solar hybrid microgrid application. I'm sharing microgrid case study, which shows the saving we can get from adopting solar hybrid system. The old solution usually is diesel genset. The OPEX you can see in the list is quite high. It comes with operation manpower salary, diesel costs, transportation of diesel, oil filter replacement, preventive maintenance services, repair and overhaul of genset. But if you utilize the hybrid system, the maintenance is relatively very low. Next slide, please. In look at this before my client before my client adopt hybrid system, they are using diesel genset only, which consume about 290 liters of diesel every single day. And on top of that, they need to deliver diesel every day as well. After adopting this hybrid system, the solar PV system is generating 1.9 megawatts hour per day. This also refer back to 190 liters of diesel saving, which is about $323 per day saving, and it's about $117,000 per year. Next slide, please. My client also contributes to cleaner environment as part of corporate social responsibility, CSR. By using 1.9 megawatt hour solar energy per day, they are saving 1.33 tons carbon dioxide every single day, which equivalent to 5 to 6 trees seedling per day. Next slide, please. Other than tangible benefit, there are intangible benefits from utilizing solar as well. It helps reduce manpower and human contact, reduce carbon emission, which no air pollution, prevent oil spill, no sea or soil pollution, which hurt your crops, prevent sound from diesel generator, there's no sound pollution, which potentially improve production and quality of your livestock. Provide shading via solar panels. Solar panel as heat insulator and act as roofing. No exposure to fuel price fluctuation. Next slide, please. Application of solar PV system for farming. As you can see in the picture, you can do it as a greenhouse system. The glass-to-glass solar panels as roof at the same time allow sunlight to go through while generating electricity. Also for the storage room or shelter area, you can utilize the lightweight Meditech BIPV solar panels, which building integrated photovoltaic panels, as roof itself while generating electricity. For land, we usually call it solar agriculture. As you can see from the picture, the solar panels can be mounted in such a way that it provides sufficient sunlight for crops and provide some shading to reduce crops dehydration while generating electricity. Next slide, please. Application of solar PV system. This is the project that I just completed. This project shows solar PV hybrid system application on a fish farm, which combines coupling system on Smart Fish Farm number 1 and Smart Fish Farm number 2. Smart Fish Farm number 1 is using AC couple, while Smart Fish Farm number 2 is using DC couple. Combining them is an AC-DC couple system optimizes the charging and operation need of electricity. Next slide, please. As for AC couple, the system optimized during full sun period. You can use the electricity with less losses. A DC couple system is optimized during low or no sun period, which is maybe nighttime, because the energy go to storage first, so you have less losses for energy charging using AC coupling. To combine them is AC-DC couple system. So it shows that we optimize the entire electrical system for client usage. Next slide, please. Process flow of adopting microgrid system. On the average process, it takes about 5 months. We start with collect information of patterns of electricity usage and how much is used. Then we design according to client needs while meeting client budget and objective. After that, we start the installation at site, electrical commissioning, energy management system fine-tuning, system operation monitor. Then we hand over the project and you can enjoy your clean electricity. Next slide, please. I think that's for my presentation today.
Thank you very much, Mr. Leong. After hearing about how farms adopt clean energy and increase their energy efficiency, you must be wondering what kind of support is available. Ms. Chang Siu Chuan from NEA will share more details about the Energy Efficiency Fund and how you can tap on it. I would now like to invite Siu Chuan, please.
Yeah, thank you. Good afternoon to all of you. I'm Siu Chuan from NEA, and it's a pleasure for me to share about our Energy Efficiency Grant, or E2F in short. Next, please. So this is the agenda for today. I'll be covering the E2F grant, followed by the Energy Efficiency Technology Center, or in short, the EETC. This is a joint collaboration between NEA and SIT. Next, please. Next, please. So E2F is an umbrella scheme which consolidates separate grant schemes to support the energy efficiency efforts by the industrial sector. So E2F consists of 5 grant schemes. I'll elaborate on the first 3 components in details later. So the 4th component in red is the resource efficient design. So this involves conducting design workshops to identify resource efficient measures that could be integrated early into the design stage of new facilities or major expansion projects. And the 5th component is climate friendly refrigerants for chillers. So as this is a new grant, details will be released at a later date. So just keep a lookout for it. Next, please. So let me start with the energy assessment grant component. So the objective of this grant is to incentivize industrial companies to engage accredited energy service companies, or in short, the ESCOs, to carry out detailed engineering appraisals so as to identify specific measures for EE improvement. Okay, so the grant co-funds up to 50% of the qualifying costs, capped at 200K. Consultancy fees, instruments, or evaluation tools can be could be supported as part of the qualifying cost. So to be eligible for this grant, the owner-operator has to be registered in Singapore, the industrial facility cited in Singapore, and companies must have conducted a preliminary energy assessment at the point of application, but of course not the detailed energy appraisal. Next, please. So let me move on to a second component of the E2F grant, which is the energy efficient technologies. Next, please. The EET scheme encourages companies to invest in energy efficient equipment or technologies. So the co-funding is up to 50% of the qualifying cost. Qualifying costs that could be supported include equipment or technology, professional service, external manpower. So EET grant has 2 additional criteria. The first criteria is that it is only for Singapore registered owner or operator of manufacturing companies. So this means SSIC code of 10,000 to 32,000 cited in SG. And the second criteria is that the annual group sales turnover must not be more than $500 million. Next, please. For the project to be considered eligible for the EET grant, The project must involve the installation of EE equipment with proven track record of energy savings in an industrial facility. And secondly, it must result in measurable and verifiable energy savings. So some examples of eligible projects include LED lamps, 4 ticks of better air cons, IE4 or better motors, central chill water system, compressed air systems, etc. So inclusion of VRFs will be effective from the 4th quarter of 2020. So just keep a lookout for them. Examples of non-eligible projects include like black box solutions, and do also know that solar PV installation is not eligible for EET. Next, please. Okay, so measurement and verification has to be conducted before and after the installation or replacement of the equipment. And we have also further simplified the application process for projects such as LED lightings, air cons, and motors. So for these projects that is mentioned, there is no need to do MMV. Do also note that the grant is unable to support installation of energy efficient equipments at new sites if there is no baseline to compare with. Next, please. So this is the typical payback period of EET. So you can see that it ranges between 3 to about 4.5 years. Every $1 invested in energy efficient technologies has a return in energy savings ranging from $2 to $4. So it's quite good. Next, please. So the third grant which I'll be sharing today is the Energy Management Information System, or EMIS in short. Next, please. So the EMIS is a new grant, it's a relatively new grant that's rolled out in end of 2019. The grant encourages companies to put in place an EMIS, which could enable them to effectively manage energy use in a structured manner. So this grant co-funds, could you go back? Next. Yeah, okay. So this grant co-funds up to 50% of the qualifying cost. Examples of qualifying costs that could be supported include like equipment and materials, professional service, software and IT. So to be eligible for this grant, it is pretty similar to the first grant component which I have explained earlier on, just that take note that EMIS has to be commissioned within 2 years from the grant approval. Next, please. So EMIS should cover all significant energy consuming systems. Otherwise, justification has to be provided. So some of the project features include, it should include the real life monitoring and tracking of energy consuming systems with appropriate indicators, followed by customized reporting to different user levels, alerts to highlight the inefficient performance, and hence rectification actions to be followed after that. And the data should also be captured at appropriate intervals and stored over a period of time for meaningful data analysis, as well as assessment of their system performance. So next slide, please. So let me move on to the second agenda of today, which is the EETC. So EETC is a collaboration between NEA and SIT to boost industrial capabilities. Officially operational on 16 June 2020. EETC is headed by Prof. Locke, supported by professionals of different skill sets ranging from electrical, electronics, chemical, pharmaceutical, infotech, mechanical engineering. So EETC is aimed at achieving 3 outcomes. We will address both the short and long-term capability building needs in the local EE ecosystem. So they include applied research to catalyze EE improvements at SME through the provision of energy consulting services, upskill existing engineers or EE practitioners through provision of continuous education and practical hands-on training, train a pipeline of engineering undergraduates in industrial energy efficiency. So SMEs plays a significant role in Singapore's economy, making up 99% of all enterprises and hiring more than 70% of the workforce. Compared to large MNCs, SMEs may lack the resource and capabilities to identify and implement energy efficient improvement measures. So this is when EETC can come in. So you may ask, what are the advantage of engaging EETC? So SME on board the program will receive a diagnosis of the facility's energy performance. And of course, that is not all. Based on the diagnosis, EETC will also provide a list of energy efficiency improvement measures and work with SMEs to implement the solutions to improve the EE of the facility. So SMEs could also work with NEA to implement the recommendations through the E2F grant. Improved EE means lower energy costs and hence enhance business competitiveness. On top of that, both the SME staff and the student will gain actual experience working on real-life EE cases to build up their competencies. Next, please. So EETC aims to provide low-cost, high-quality energy assessments for the SMEs. The full fee of a detailed energy assessment is $15,000, and for now, EETC is offering it at a promotional fee of only $1,000. Examples of systems that EETC could provide include like lightings, heating system, cooling system, compressed air system, motor-driven system, chilled water system, etc. So I'm sure your facility involves at least one of these systems. So what are you waiting for? Next, please. Yeah, feel free to contact us to embark on your EE journey today. Yeah, thank you.
Thank you very much, Tze Chuan. It's now time for our panel discussion, which is on transforming the farming scene in Singapore with clean energy. Joining the panel session are Christoph, Vincent, and Liu Beng Kwang, who is the Senior Manager from NEA. This session will be moderated by Mr. Chew Chi Bin, Director of SAFEF. Mr. Chew, you may proceed with the panel discussion. Thank you. And just a reminder to our participants, you can use the chat box or your raise hand function to ask any questions. Thanks.
Hello, Vincent, Chris, and Mr. Liao. Welcome you all. Also, I enjoy a lot of, today have a lot of information. Okay, now a few questions I would like to ask. First thing is, I know there's a Paris Agreement, Singapore signed a Paris Agreement. So by year 2030, I think we're going to reduce 36% of the carbon emission. And also coincide with this, our SFA had actually set a target for producing 30% of Singapore nutritional needs by year 2030. How does this green energy help to fulfill this both for the Paris Agreement, also SG 30 by 30?
Okay.
Maybe Chris,
yes, maybe I can take that question. It's a very good one. And when you look at what the national goals are, of course, it doesn't matter which individual is doing the reduction in energy consumption or the displacement of conventional energy by renewable energy. That's the lovely thing about it. We can all play our part, no matter how big or how small, because the CO2 emissions are shared globally. And therefore, any industry, any home, any farm, which reduces energy consumption, so in other words, eats less, is contributing, and any building or any farm which displaces fossil fuel using renewable energy is also contributing.
Okay, thanks for the. Next question is, how to use, is it using the green energy is a sustainable solution? Just now, based on Chris' presentation, the ROI is 4.8 years. It's fantastic. I think this time is the first time I come across this figure. I've been studied maybe 10 years ago. They're talking about 15 years, 20 years. I almost gave up all the PV and
that's right. Okay. I remember talking to you about 4 years ago, and it wasn't quite attractive enough. Maybe we should have a chat afterwards.
But your return is based on you don't use a storage, many battery, all right?
Right.
You don't use a battery to storage. So if those people like marine farm, actually they need to use a storage system to store the energy for the night use. So the return cannot be 4.5.
Well, the return depends always on what your alternative is, because you're buying grid electricity at anything from 10 to 20 cents. The fellow on the farm who's using a diesel genset is not paying 10 to 20 cents. Their effective cost of electricity through the diesel is much higher. So it actually does work out, especially the further away you are, the more your transport costs for the diesel, the more your maintenance costs. And we find that even with the batteries, they're saving money. And I think Hu Yao gave us very good figures there to illustrate the case.
Another question I want to ask is, can a few farms, nearby farms, then they combine all the PV project at one time? Is there any advantage over there?
There is an advantage, I guess, if they join forces to combine their purchasing power and get a bigger quantity discount. It's something many customers have raised, but funnily enough, they're seldom able to coordinate enough with each other. They all have different schedules. But in theory, it's possible. You could do cooperative buying and get a bigger discount, yes.
Okay. My next question is, what is the best practice in overcoming all the challenges and limitations for this green energy in Singapore context, also for the farming context?
Vincent, do you have a bit of overview there?
Yeah, I think I look at it in this issue is mainly two things, because a lot of people talk about clean energy, PV, but they always forget about EE. Actually, EE is what Christoph said. You have to make sure that eat less, and do a bit of exercise first before you can buy an exercise machine. It's the same thing here. A lot of people, they didn't know that actually they can save so much, and then they just implement it because it's affordable, it's cheap. They just do it first. But the thing is that the running cost actually costs them more. So if you do it correctly, actually everybody do that. Actually, it helps to reduce carbon emission for the whole country. So then we've come into PV to further reduce. That's the reason why I think government very actively, like NEA, encourage all industrial to go into audit the building and show them the potential, how much they can reduce. You'll be surprised they can reduce 20-30% of their energy.
How do our members, our farming members, tap into your knowledge to have energy efficiency? How can they do that?
Okay, just now I think Ms. Chan actually showed you the fund, right? So there is this NEA fund actually to help this industry, but I don't know whether it is suitable for this industry. Yeah, maybe Ms. Chan can share. So this is actually to encourage all the industry, be it farming industries, to utilize this fund given by the agency to support.
So maybe Mr. Liao.
Yeah, currently the energy efficiency fund is for the industrial manufacturing companies to help them improve energy efficiency. Encourage them to retrofit their current system with energy efficient one, and hopefully at the end of the day they will be able to reap the savings from this investment. Why is it for manufacturing companies? It is because government has committed to plow back the carbon tax that's going to be collected within 5 years, to plow back into to help industrial companies improve the energy efficiency through this grant. So actually this pot of money is co-administered between NEA as well as EDB. So for the larger companies, how we segregate this, our work is for the larger companies in terms of annual sales revenue, they will go to EDB, and EDB will help them to evaluate their grant applications. And then for the smaller companies, they will come to us, NEA, and NEA will help to look into the funding applications. Hence why the fund is being used for the manufacturing companies. I think there's these agricultural companies, if they do fit into the manufacturing activity, business activity, they can also come back to us. They can approach NEA to inquire from us, and if there's a good fit in terms of the eligibility criteria, there's a good fit, we will definitely help them look into these projects and advise them accordingly.
Yes, you see, for our livestock member is mainly the three egg farms. I understand their energy consumption per year is close to $1 million. And latest the big fish farm, they maybe electricity, they may use a few million a year. So I sincerely NEA should consider maybe to help them to study into this electricity energy so-called efficiency is very critical to them.
Yeah, as long as there are farming companies that are interested to apply for this grant, do come to us, and then we will talk to them on a case-by-case basis, and if we can help them, definitely we will try to do something about it.
Okay, another question I'm going to ask is how to getting started to increase the bottom line and with the green energy and energy efficiency.
Sorry, can you repeat that question?
Yes, how to getting started to increasing your bottom line with the green energy and energy efficiency. How to do it?
Okay, maybe I can start with the solar. So I'm assuming here that you are based on land. So it's a conventional case. You have your own building, you have your own roof. First thing to prepare is the plan view of your roof, because that's the area you have available. And then if you bring those drawings, plan view, section and elevation drawings to one of several solar companies in Singapore, and you can also check with Seas whom they recommend, then they can prepare the system size for you and tell you how much that will cost and how much it will generate. Next thing you should look at is what is your electricity consumption. Now, you may only have the monthly figure, maybe 10,000 kilowatt hours a month. Ideally, you can get a half-hourly load profile from your electricity provider. That'll tell you how your electricity is consumed throughout the day. Then we can plot that against what we believe the sun is going to generate and forecast how much you consume, how much you export, and that will tell you the economic return. And then you've got basically all you need to know to make up your mind. Get 2 or 3 quotes, as always, and find the one that convinces you the most in terms of price and effectiveness and basically good technology.
Okay, so when you build the substation, do you need to build in the, let's say, gear, interchange gear, so that make sure that PV can link together with the grid, or the roof? Should you use a special type of roofing, like kick lockdown roofing? Should you allow for the loading?
Yes, you're getting into very good details there. So BCA also has recommendations on building a PV-ready roof. So the ideal case is a metal roof, something like clip block or CalZip, which you can clamp the panels to the roof without penetrating it, so you don't void the waterproofing warranty on your roof. And roof load in Singapore standards are at least 0.5 kilonewtons per square meter. That's about 50 kg. So the roof can take the weight. The panels will add only about 14 kg of weight, plus or minus some wind load. So on a normal Singapore standard roof, the weight is not an issue. Yes, that's that question there. And you asked about the substation. Substation is SP's job, but they will bring the cable into your main switchboard. And ideally, if you're building a building new, you should cater for some spare breakers to feed into, because it's much cheaper to do that when you construct than to have it retrofitted. So you can make your building receptive to PV, even if you don't decide today to install it, but you want to allow it for future. make your life easy.
Thanks, Chris. But the greenhouse with a glass panel, and can they use a solar panel to tap on the solar energy?
I missed that. Can who use the solar panel?
Yes, the greenhouse, because they
greenhouse.
They have to allow the sunlight to come in. The
Yes.
same time, how can they tap the solar energy also?
Tricky question. You got some sneaky questions there. Okay, so you have two competing uses of sunshine. Of course, your plants are also solar plants, aren't they? They use the sunshine for photosynthesis. And if you put a solar panel on them, you are depriving them of a certain amount of sunlight. Now, not all plants need the full sunlight. Some of them are happier in slightly shady conditions. And that's an ideal combination. But otherwise, if you were to cover your greenhouse completely with solar panels, it would be a bit self-defeating. So not ideal for every case. If you have, however, normally a metal roof, which obviously the light cannot penetrate, then by all means, you should put the panels on top of the metal roof.
Thank you. That's all my question.
Thank you, Your Honor. Hand over to the next victim.
Maybe Mr. Chiu, I share with the team, with all the industry, how you should go about looking at your farm. Okay, let's separate into existing farm and new farm. So existing farm, what you need to do is that talk to CIS, and then CIS will arrange ESCO like us go and visit your farm and see what is the potential we can help you to reduce energy consumption. Okay, based on my knowledge of the farm data, we have farms operating $10,000 per month. We have farms operating $100,000 per month on energy bill. So it's quite varied, you know. So, but the thing is, doesn't matter. Talk to CIS. We will arrange. Go and take a look on the farm and see what we can do to see how to reduce consumption. That is for your existing farm. And then with that, then we see whether is there any potential we can get a grant from NEA to help you to reduce your expenses. Okay, which NEA would definitely like us to write proposal to tell them that whether how much we can save for you. Yeah. That is what Beng Guan want to see.
So right? To add on to Vincent's point, there is this grant to help existing companies, industrial companies, to look into to evaluate the energy performance of their facilities. On the other hand, I think that just now Siu Zhen's presentation has also covered about this Energy Efficiency Technology Center that is being partnered with, that NEA partners with SIT. So this is another area that companies could consider. It's not to go direct, how to say, confrontation or business competition with the ESCOs, but it's another alternative where companies can look into how they want to, whether they want to engage an ESCO and get part of the fund, this ESCO, part of the cost, auditing cost funded by the this grant, or they can also get Energy Efficiency Technology Center assistance to look into their systems. Sometimes the companies are very small. They see that the number of systems are not many. So perhaps they could look into EPC to help them to conduct energy assessments for them. And it's like a health check to help them understand where are the energy consuming systems and where the opportunities of savings are. Yeah.
Okay, panelists, hi, sorry. We have a question from the chat room from Mr. Samuel Kui. The question is, besides solar panels, are there any other ways to harvest sunlight, i.e. directing light into the farm and rackings?
Yes, of course you can do that. It's a little bit trickier, and that might be some kind of technology for which the government will offer a grant. Generally, grants are available for more cutting edge, more experimental trial solutions. So it's been done before by certain architects to use mirrors which vary their angle according to time of day and time of year to direct sunshine into a building. But it's something that I don't think many companies in Singapore have experience with. I can't claim to to know how to do it very well. So I won't be able to sell you a system for that. And the other one, of course, is hot water. If you need to heat water for your processes, the traditional water heater is also still available and worthwhile for anybody who needs a lot of process heat.
Thank you, Christoph.
Maybe we could open the floor for any questions from our participants, SafeF members. You know, if you have anything you would like to ask our panelists, this would be a good time. We have a raise hand function at the bottom of your screen. If you would like to ask a question, we can unmute you.
Right, while they're thinking about that, there's also the further question I didn't fully address, Chi Bins, about combining solar with plants. There is new research technology, which is kind of the ultimate in solar panels, if you like. It lets visible light through, which is what our eyes need and what plants generally need, and traps the UV and the infrared and converts that to electricity. So this is almost like the impossible dream. You've got a window you can see through, and yet it harvests sunshine. So wonderful stuff. Not exactly off the shelf available mass production at a cheap price and reliable. For that kind of thing, maybe you wait 10 years time. If you really want to try experimental stuff, then of course, put up your hand, go for the grant. And but I think you will not be making much money with it today. To save money, go with the tried and tested, the proven. So energy efficiency, of course, and conventional solar PV. Well, those two do the job.
Also, Mr. Chu, maybe as a follow-up, we can offer, if any of the SafeF members would like to have their facility audited for energy efficiency, or they would like to see any solar, explore the possibility of solar, please reach out to SEAS and we can connect you to our members, so that I think our members would probably be able to do the first one, I think free of charge, just as an exploration. And from there, if there are any opportunities, we could explore that further.
Yes, we will reach out to our members and give them all this information, and hopefully they can use this facility.
Yeah, sure, thank you.
Sure. We have two questions in the chat function. One is from Gina Ko. We have helped some farms in Singapore for solar. On Mr. Chu's question on grant, there is a basic capability grant that he can tap on for farms. Is there anything you would like to elaborate, Mr. Chu?
I think that was informing him. You need to ask Gina.
Ah, okay, sure. Okay, sure. Maybe I'll go to Stella Cha's question then. Can I know, for installation of solar systems in farms, how much and how long the solar energy can be strong enough and sustain the usage? Are there any maintenance for the solar system after a few years using?
Okay, good question. So solar panels from reputable manufacturers warranted to last for 25 to 30 years. At the end of that period, they will still be generating, depends on the manufacturer, between 80 and 85% of their initial output. So this is not like your washing machine, which dies after 1 year. You're talking still getting 85% performance after 25 years. That's very, very good. Is it maintenance free? Nothing is maintenance free. You do need to do a once-a-year inspection, and there could be periodically small, let's say, isolators or contacts which may break down. As a rule of thumb, quite conservatively, you should be spending less than 1% per year of the initial capex on maintenance. So it means even after 20 years, you spent less than a fifth of what you originally paid. So it's a good investment.
Okay, do we have any other questions from the floor?
There was more to the question there, especially during
that's
the end of the year, the sunlight is not there every day. Will they conserve energy? Okay, so the end of the year, December, January is slightly less sunshine than you have in February or March, but from year to year it can vary, or rather from month to month it varies. But generally, the variation from one year to the next is very minimal. So typically not more than plus or minus 5%, which means that each year you can be fairly sure of how much energy you will generate and thereby how much you will save. Of course, that generation takes place only during the daylight hours, so between 7 in the morning and 7 in the evening. At nighttime, it's 0. I know this. And but the prediction on an annual basis is very reliable.
Sure, we have one more question from Samuel.
I can read the question out. So PV systems generate DC. Can they be used to power the farm's LEDs directly instead of converted to DC AC, which reduces efficiency? It can be more complicated doing that because the solar panel generates on average about 40 volts each, and you connect many of them in series, so you end up with 800 volts or so in series. Your LEDs are often only 5 volts, so you still need to convert from one DC voltage to the other. I'm afraid there's almost no easy way to get around the conversion of energy from one form to another. And generally the equipment is cheaper and better established from the 400 volts AC or 230 single phase through conventional equipment to drive your LEDs rather than customizing something super special from the PV panels. So go with what's proven, what's tried and tested, and then you'll have less maintenance.
Sure. One more question from Stella. Are the solar systems very costly for farms? No special rates for farms?
Everyone gets a special rate. In the end, no, it's a matter of business. So the saving for the farm is similar to anybody else. And go ahead and get several quotes. You'll find the person who gives you the best deal, the one who wants to do the business most with you.
But Christoph, right now the solar electricity cost is very competitive with our fossil fuel electricity, what the price is today, right? And in some cases, it's even at a discount.
It is cheaper on almost all cases. So when if you put, that's why the question's a bit funny for me. Is it costly for the farm? There's no point putting solar on your farm if it's going to end up costing more than you just buy from the grid. Everybody who installs PV today is doing it to save money on their electricity bill, and a farm is no different from a company. Thanks for clarifying that, Kavita. It's a good point.
Yeah, I think the message is that solar today is cheaper than traditional electricity in most cases. Energy efficiency is definitely going to save you money. You know, so do reach out and let's see how we can help you to save money. You know, this could be a new area. I think there's not much work that's been done in the space of RE as well as EE for farms. So I think our members are equally eager to help you. You know, just do reach out and you know, if you have the commitment, we definitely would like to do that. As you can see, one of our members shared how, you know, from Megawatts, how they have already done work with fish farms and offshore facilities. So it's very possible.
Yeah, very, very few companies or individuals can afford to do the Bill Gates thing and give up lots of money for the general good. We give some pocket money to charity, but most companies are there to make a profit, not to save the environment. And the news is that energy efficiency and PV are there to help you make a profit. We also save the environment, but I see that as a fringe benefit. The real benefit is saving you money.
Yeah. You just check on the ROI. If you can recover in 4.8 years, then you still can make money for next 20 years.
That's a very good way of looking at it. And nothing wrong with free, huh?
Yes, yes, that's right. And then we have some companies that also have the model where you can just buy electricity from them for 20 years. It's a power purchase agreement and you don't have to pay anything upfront. That's also a possibility. So there are many options available, and you know, you can explore that. We are very happy to work with SafeF to see how we can arrange some of these first rounds of audits maybe.
There's a question about whether solar systems will be hit by lightning. They don't attract lightning any more than a regular building roof does. So there is always that very, very small risk that your building is hit. A direct strike will damage the panels and or the roof. But much more often what happens is lightning strikes nearby, and the electrical field induces a surge in your building, which could therefore spoil electrical equipment. So any properly installed solar system is protected against that. All the metal parts are grounded to the building's lightning system, and we put in surge protection devices so that a lightning surge will not propagate into the building. So it's not really a problem in Singapore.
Let's be the most energy efficient farm in Singapore.
Right on, okay.
Yeah, let's work together and do something different.
Energy efficient vegetables. Yeah. And solar powered vegetables and fish and chickens.
Get those eggs, huh?
Yes.
Sure. Thank you very much to all our panelists for such an insightful discussion. We really appreciate it. So before we end the session proper, we would like the participants to take some time to fill in the feedback, which is popped out on your screens right now. We will keep the poll up for about 40 seconds. So maybe you could help to do the feedback poll for us. Thank you.
I think while this is up, I would just take this opportunity to thank Mr. Chu and our speakers, Christoph, Vincent, Beng Kwang, as well as our speaker from Megawatt, our members who joined us today, SafeF members who joined us today, as well as the SafeF Secretariat who has worked very actively with us to put this together. I think this is first in the series of many such webinars or events or collaboration that we look forward to. Farming is a very exciting industry that touches all our lives, and we look forward to having some more energy efficient and solar power grown vegetables and other food products in the near future. Thank you so much.
Thank you all.
Thank you very much.
Thank you, everybody.
Thank you very much, everyone. Thanks a lot. We have now come to the end of the event, and I hope you have gained much insights from the presentations and discussions today. Once again, we thank all our speakers and participants for joining us today and wishing you all a pleasant day ahead. Thank you.